This capstone brings everything together. You'll build an autonomous Web3 AI agent that can reason, read on-chain data, interact with wallets or smart contracts, follow guardrails, log decisions, and deploy as a portfolio-ready prototype. At this point, you've built the core pieces: agent reasoning, tool use, wallets, smart contracts, event monitoring, security, testing, and deployment. The capstone is where those pieces connect into one production-minded Web3 AI system. For your capstone, think beyond "I built a chatbot." The goal is a controlled, autonomous agent that completes a real Web3 workflow. It should reason through the task, use on-chain data or contract interactions, and recognize when not to act. Safety is part of the product: approvals, spending limits, confirmations, and warnings. Then prove it works with logs, tests, and a short demo that shows decisions you can inspect. Most autonomous Web3 agents use a similar stack. Inputs come from people, scheduled jobs, events, or external systems. The agent core interprets intent, recalls context, routes tools, and tracks workflow state. Data tools read from APIs, RPCs, indexers, and contracts. Before anything irreversible happens, policy checks, approvals, and guardrails stand between reasoning and execution. Wallets execute only controlled actions, while logs and monitoring surround the system, so decisions can be audited, debugged, and improved. Whatever capstone you choose, use the same build path. Start by defining the user, workflow, decision boundaries, and success metrics. Build read-only data tools first, so the agent can observe wallets, proposals, invoices, tokens, or ownership without taking action. Then add reasoning and recommendations. Only after that should you prepare transactions or testnet execution. Finish with guardrails, logs, evaluation tests, deployment, and a short demo script. In this capstone, the AI acts as a safety copilot inside a crypto wallet. It reads balances and recent activity, translates swaps, approvals, and gas fees into plain language, and flags anything suspicious. The key is restraint. Payments are only prepared after the recipient, amount, network, policy, and explicit user approval all check out. Think of the wallet copilot as two connected systems, one that can observe freely and one that must act carefully. It reads balances, transfers, NFTs, receipts, and metadata through RPCs, indexers, or wallet APIs. Then it classifies activity and applies risk rules for approvals, phishing patterns, suspicious contracts, and abnormal spending. If action is needed, it creates a draft, simulates outcomes, validates recipients, and waits for explicit confirmation before anything is signed. Another capstone option turns invoice handling into a controlled agent workflow. The agent reads the invoice, extracts the vendor, amount, currency, wallet address, due date, and line items, then checks them against business rules. If the vendor is unknown, the amount is too high, or the token or network looks wrong, it routes the case to a human. Only approved payments are sent on testnet, and every transaction is logged with a receipt and hash. Payment agents need a stricter safety model because a bad transfer may not be reversible. The agent can extract invoice details, but deterministic rules decide whether payment is allowed. Validate identity, amount, network, token, and recipient. If the invoice is high value, the recipient is new, or anything changed, require human approval. Then simulate the transaction before sending. Every step should be logged, so the final payment is explainable and auditable. A third option is a governance analyst for a DAO member. The agent watches proposal sources, pulls in forum context and snapshot data, and turns messy discussion into a clear decision brief: intent, deadlines, financial impact, risks, and voting choices. It also checks whether the user can vote, including delegation or eligibility. The key design principle is agency. The assistant can recommend and draft, but the human makes the final vote. A governance agent starts by watching for events, new proposals, open voting windows, quorum shifts, and approaching deadlines. It pulls proposal text, discussion links, voting options, current totals, and eligibility data. The output is not a verdict. It is a sourced brief with pros, cons, stakeholders, and open questions. Before drafting any vote or signature, the agent checks wallet ownership, voting power, proposal ID, and deadline. It labels uncertainty, avoids advice, and leaves final judgment to humans. This capstone focuses on watching risk, not placing trades. Your agent continuously reads wallet balances, lending positions, liquidity pool exposure, token approvals, protocol events, and market data. It then converts those signals into severity levels: liquidity disappearing, volatility spiking, suspicious transfers, oracle changes, fake airdrops, or honeypot behavior. The key design choice is alerting. Decide what threshold matters, who should be notified, and whether the response goes to email, Discord, Telegram, webhooks, or a dashboard. This option combines wallet authentication with personalized community support. A user connects their wallet and signs a message, proving ownership without sharing private keys or seed phrases. The agent checks NFT contracts, token rules, or membership tiers to determine access. From there, responses can change based on holder status, role, or contribution history. Practical workflows include creator keys, onboarding, event access, perk redemption, and helping members discover gated content. Final integration is where your agent stops being just a prototype and starts becoming evidence. Test the normal workflow, then deliberately stress it with edge cases, missing data, invalid inputs, and adversarial prompts. Confirm that guardrails block unsafe actions, especially unauthorized payments or unsupported contract calls. Choose a deployment pattern that fits your project. Then rehearse a concise demo showing the problem, architecture, live run, logs, safety controls, and outcome. You've now connected the full builder lifecycle: agent design, blockchain integration, safety controls, logging, testing, and deployment. A Web3 agent is not just an LLM, it is a governed system. From here, harden it with audits, monitoring, key management, users, and partners. Build safely, automate responsibly, and ship on-chain intelligence.